Okay, hi everyone. Um, this is a little puzzle that I'm trying to figure out using my oscilloscope on my circuit. I'm not going to try to explain exactly how the circuit works. But basically, we've got the AT tiny on the left, which is about there, driving two solid state relay, MOSFET relays there and there. That on the side towards us is the input driver side, so that drives the opto-isolators, the LEDs, and on that side we have the capacitor. The capacitor basically gets switched so that at in one phase it is connected to across one battery, so that the positive of one battery goes to the positive side of the capacitor and the negative goes to the other side. Then it's disconnected, then the other battery's positive gets connected to the positive of the capacitor and the other negative connected to the negative of the capacitor. So the capacitor sort of floats relative to ground. And that, I think, is what is causing the problem that I'm seeing. What I'm seeing is, on the the oscilloscope, we see the yellow signal is the turn on for the first channel, which is the higher cell. The negative, the lower cell, is out a bit, so I'll show you. Basically it's switching one on and then turn off, and then the other on and turn off. Now what I was originally interested in here was trying to figure out what the rise and fall time of the capacitor was. The capacitor should, if the two cells are slightly different, it should go up a bit to as the higher cell charges it up, and then down a bit as the lower cell discharges it. And therefore, relative to ground, what we should see is the capacitor floating between the negative side of the capacitor floating between ground and one battery's voltage, so the negative side of the higher cell, then then as the other phase turns on, the negative side of the lower cell becomes ground, and we should go to ground. So here I've got the yellow probe on one side of that input, the light blue connected to the other side of the input. The pink probe, all of the grounds of the probes are connected to a common ground. So the pink probe, I'm just going to connect to the positive side of the capacitor. Sorry, that's the dark blue. So that's let's move that to the negative, because that's supposed to be the negative side. So what we kind of see is what we kind of expected here. When the cell is connected to the higher side of the battery, the negative side is connected to 4 point something volts which is offset from the ground of the battery, and you can see there that there's if I zoom in, there's a little delay for the MOSFET to turn on, and then it starts conducting, and then the capacitor comes up to to 4.2 volts. So that makes sense. That's basically the MOSFET turning on, which is one of the things that I want to measure, because I need to know how fast I can switch it and how long that capacitor takes to actually get charge. And that sort of gives me an indication. The interesting thing there is that we're seeing that strange power fluctuation based on lighting up the LED. And the LED basically runs every sort of, I think it turns on at cycle 20 and turns off at cycle 25. So there's a bunch of cycles. The LED going on and off there is just basically to tell me that yes, the circuit is actually still working. Okay, that's kind of amusing. So that's kind of doing what I expected. And the turn off, when the MOSFET turns off, this is where I'm a little more puzzled, because what should be happening is that capacitor should sit at that higher voltage. Both sides of the MOSFETs should be disconnected until the second signal, which is here, the lower side turns on, and at that point I'd expect that MOSFET to start charging and also start conducting, and the capacitor to go down. But instead what we see is that as soon as the MOSFETs on phase 1 disconnect, then it goes down to ground level. That's slower, and I can cope with that, but that's not when I expected. The really puzzling thing is if I take probe 3, the pink probe here, and attach it to the high side, see something really weird. Now the high side should kind of echo the low side. It should be sitting at 8.4 volts and then come down to 4.2 volts. Now it's going down to somewhere around 2 volts, but it's starting at 8, turning on at the same time as the first, which is, yep, that's exactly what I expect. It goes down to about 2 volts, so I don't know where 2 volts comes from. Then you can see on the left here, when the second phase turned on, it goes up to 4 volts, and that's exactly what I'd expect as well. But why is it sitting otherwise at 2 volts? Why there? Why not? Why is it not remaining at 4 volts and then rising up to 8 and going down to 4? What's really weird is now that fourth, which is the dark blue, hard to spot on this, but it's that one. You can recognise it by the same shape. Why is that going negative? Why is it now sitting at negative 2 volts? There's no negative in this system. Everything is, the grounds are connected to ground. The only thing that I've changed is connecting up the pink probe. Why am I getting a negative signal here? If you can figure that out, please tell me. Thanks. Bye.